Geometry section 2.2, looking at the notes. We are talking about reasoning and proof. That's what the chapter is about. We're looking at algebraic proofs. What we're trying to accomplish in this section is to show you that you've been doing proofs all through Algebra 1. Mainly you were doing things mentally. You weren't writing everything down. We are going to try to show you how to apply the concept of proofs to algebra, so that when we try to apply it to geometry, it's not near as frightening as it could be. Let's review some properties of equality. Now, first of all, a property of equality, it just means it's a property that works when you have an equation. It also says for all real numbers a, b, and c, because you're going to be using a's, b's, and c's in these properties. So as long as you're using real numbers, and at this point in your life, you probably only studied real numbers, these properties for equations will be true. For example, the reflexive property of equality. And yes, you need to memorize this. This is important. For every number a is equal to itself. Example, guess what 3 is equal to? 3. That may seem funny or ridiculous, but it is a really important property. Symmetric property of equality. If a equals b, then b equals a. You ever solved a problem and you get to the end and you end up with 3 equals x and you're kind of annoyed because you want the x on the left? Well, you can change it so the x is on the left side of the equation and the 3 is on the right. That's the symmetric property of equality. That says you can take the left side of the equation and put it on the right, and the right side of the equation and write it on the left. Transitive property of equality. This deals with 3 things: an a, b, and a c. If a equals b and b equals c, then a equals c. Let's see if we can make sense of this. If x equals 3 squared and 3 squared equals 9, then what conclusion can we draw from this? X equals 3 squared. We know 3 squared is 9. Doesn't it seem reasonable to assume then that x is the same as 9? That is the transitive property. Addition and subtraction properties, you use these on the daily. If a equals b, then a plus c equals b plus c, or a minus c equals b minus c. This plus or minus, you wouldn't use these simultaneously. What this is saying is, if you're going to use the top symbol here, use the top symbol here. Use the bottom symbol here, use the bottom symbol here. So here's an example. You're trying to solve an equation. You have x minus 3 equals 5. You're trying to solve the equation. What would you do? You would add 3 to both sides of the equation. Guess what property that is? The addition property of equality for real numbers. You were adding the same number to both sides of the equation. Someone else could come here and say, I'm going to subtract a negative 3 from both sides. That makes it the subtraction property of equality. You get the same answer. Multiplication and division properties of equality says that you can take any equation and you can multiply both sides of the equation by the same number, or divide both sides of the equation by the same number. So let's say that we had, since I'm hooked on 3's, let's continue to use 3. X divided by 3 equals 11. If you wanted to multiply both sides of the equation by 3, you would get x equals 33. We multiplied both sides of the equation by 3. That is the multiplication property of equality. If we were to divide both sides of the equation by the same number, that's the division property of equality for real numbers. Now, the distributive property, everyone remembers this name, and there's a distinct reason why. Because your teachers that you've had that have used it have mentioned this property every time they've used it. But it's likely that they haven't mentioned these properties every time they've used them. Distributive property of equality for real numbers.com. If you're multiplying a number times a sum or a difference, this could be a plus or minus here, then that's the same as saying the number that you're multiplying by each of the terms in the parentheses. So if you had 3 times x minus 4, that's going to be equivalent to 3x minus 12. You know the distributive property. Everyone always does. Substitution property of equality is always the most complicated. It seems like it wouldn't be, but it is. If A equals B, then A may be replaced by B in an equation. So if you have an equation, 3 plus 7 equals X, and then you say, well, 3 plus 7 is 10. That's obvious. So 10 is X. That's a substitution property. You substituted 3 plus 7 with 10. Now, on the Ohio Geometry end of course test, they also include some terms for this instead of substitution for this example as combining like terms. And because they will accept that as an answer, I will. And before they would accept that as an answer, I wouldn't, but I will succumb to what they want. So replacing something is substitution. Now, some people think, well, this is the addition property. We added 3 and 7. But the addition property of equality says you're adding the same number to both sides of the equation. Did we decide to add a 7 to both sides of the equation? No, this is substitution. Let's look at some examples. Tell which property justifies each conclusion. Before you decide which property, let's first try to figure out what happened. So our given is this fellow right here, 6x plus 2 is 12. Our conclusion is 6x minus 10. So what happened from here to here? I would venture to say we subtracted 2 from both sides of the equation. Well, what property from algebra says we can subtract 2 from both sides of the equation? That is the subtraction property of equality for real numbers. I know what you're thinking. Do I have to write all of that? Mr. McConnell is an insane person. You do. We can simplify some of this by using symbols, but we are going to later have other properties that are not of equality. We're going to later have other properties that are not for real numbers, and we want to distinguish between the two. This next one I will use an abbreviated form of that. Given 45 equals x, our conclusion x equals 45. But what just happened? The left side of the equation became the right side. The right side of the equation became the left side. That is the symmetric property of equality for real numbers. Here's how we can abbreviate this. Symmetric prop of equality for real numbers. Actually, let's not do that. Let's do this. A capital printed R with an extra vertical bar in it is a symbol for real numbers. Symmetric property of equality for real numbers. That's the best we can do for that. Be careful if you abbreviate subtraction that you use 4 letters, because if you don't, it could look like substitution. Number 3, let's see what happened. I don't know where this degree symbol came from. My apologies. I'll just put a degree symbol here. So you might first look at this and say, well, there's a degree symbol in one and not the other. What property is that? Well, that's just a typo because I'm not the smartest guy in the world. So what's happened? We took 3x minus 7x and we replaced it with a negative 4x. That's a substitution property. Let me abbreviate. Substitution property of equality for real numbers. Now you could also, what I mentioned earlier, is you could also say, in this context, substitution doesn't always imply this next thing. You could just say combine like terms. I don't like saying that because I think it's kind of ghetto. But if the state test allows it, you need to be familiar with the fact that you can say that, because if it's a multiple choice on a state test, you need to know that combine like terms is a legit answer, even though it gives me nightmares. Number 4, we have 4 times a difference equals r, and then down here we have 4 times 2 different terms equals r. Well, that's the distributive property of equality for real numbers.com. Number 5, if a equals r and r is 60 degrees, well then a is 60 degrees. That's transitive property. A takes you to R takes you to 60. We can conclude we can go directly from A to 60. That's a transitive property. Oh, number 6, what is going on? This isn't even finished. This is geometry now. Everything we've done so far in this section has been Algebra 1. So now we're looking at geometry. If B is the midpoint of segment GH, then what conclusion can we make? Well, the conclusion that we can make is that GB is equal to BH. Now, how do I know that? Unless I tell you otherwise, everything we do in here is going to have a reason. So there must have been some time this year where we had a definition, theorem, or postulate that led me to believe this has to be true. And whatever definition, theorem, or postulate that is, that would be the reason that I could write this. And that is the definition of midpoint. It's the definition of midpoint. On the flip side, a 2-column proof lists each statement on the left with a justification on the right. Each step follows logically the line before it. Fill in the missing statements or reasons for the following 2-column proof. So we are given 45 plus 2 times the difference of x and 10 equals 85. We're trying to prove that x equals 30. This first line tells you everything that has been given. Or everything that is known to be true. So we are assuming on this problem, this is 100% true. We don't know if this what we're trying to prove is actually true. If we can use rules of algebra to get to this point, then we can say that this line tells you what you must prove. We can prove that that's true. The only thing you're not allowed to use in a proof is what you're trying to prove. You can use any other thing that you know. So the first statement we have, oh, that's the original statement we had here. The reason for the original statement is always the same. It was given to us. Then we're going to look from step 1 to 2. What has changed in this problem? Well, this hasn't changed. This was an 85, now it's a 40. What happened? Well, perhaps we subtracted a 45 from both sides of the equation. That would be the subtraction property of equality for real numbers. Cool. Cool. I'm going to give you another abbreviation for some of this here that you might like. I'm going to get real crazy. What happened from here to here? We distributed the 2. That's the distributive property. So distributive property of equality for real numbers. I will allow this. Big P, big E, little o, property of equality. Not to be confused with principles of engineering, which is perhaps the finest class the high school offers. You should take it, especially if you like computers, programming, robots, math. If you're a girl, it's even better because we need good girls in engineering. Anyhow, from here to here, what's going on? We're going to add 20 to both sides of the equation. So that's the addition property of equality for real numbers. What happened from here to here? It looks like we divided both sides by 2. That's the division property of equality for real numbers. Congratulations. You've just completed your first proof. People say this class is hard. It's not hard. Come on now. Number 8. Prove that if 2x minus 7 equals 1/3 x minus 2, then x equals 3. Given 2x minus 7 equals 1/3 x minus 2. Then your conclusion, x equals 3. First statement of your proof is almost always going to be what's given. Could you write something else as your first step? Theoretically, it's possible. And sometimes the state of Ohio does that on the end of course test, and it irritates me, but you can do it. Now we just use algebra. From here on out, everyone's proof in this problem could look different. I've given you 6 steps here. Maybe it takes only 3 steps. Maybe it takes 9. Depending on how you do this problem, it can take lots and lots of different steps. Here's what I like to do when I'm doing algebra. If I have any fractions, oh, I got a fraction right here. I like to get rid of it right away. This fraction means divided by 3. What's the opposite of dividing by 3? Well, it's multiplying by 3. So if I multiply every term by 3, 2x divided by 3 is 6x. 7 divided by 3, times 3 is 21. 1/3 x times 3 is x. A minus 2 times 3 is a minus 6. What did I just do? I used the multiplication property of equality for real numbers. I multiplied every term by 3. For the multiplication property to work, when you say you're going to multiply both sides by a number, you have to multiply every term by that number. From here, I don't have any fractions. So I'm going to get my x's together. I'm going to subtract x from both sides of the equation. It's going to give me 5x minus 21 equals negative 6. If you wish to do something different than that, go for it. As long as you follow the rules of algebra, you can do whatever you want. So this is the subtraction property of equality for real numbers. Then I'm going to add 21 to both sides of the equation and get 5x is equal to 15. That's the addition property of equality for real numbers. Then I'm going to divide both sides by 5 and get x equals 3, which is what I was trying to prove. I divided both sides by 5, so that's the division property of equality for real numbers. All right, that concludes our notes. Please do your assignment as noted on the website.